hi to all also on my side. And many thanks for organizing this event and having all these nice papers. On my side, I will speak about the interconnection of the work of data spaces with what we call Meta-Orchestration platforms. So there is several projects that work on the concept of how we can manage distributed applications that are deployed over resources across the computing continuum. Okay, I'm coming from the National Technical University of Athens, and we are coordinating the Nefele project, that is one of the projects active on this domain of the meta-orchestration platforms. So I will be really short on this slide because it was also shown by Rolf in the morning, just to align among ourselves that we speak about resources ranging from IoT devices to the cloud infrastructure, and we are trying to tackle different challenges of deployment of applications that have a lot of data processing, data workflows within the way that they operate. And per part of the continuum, you may have different requirements in terms of latency, bandwidth, quality of service, privacy, security, all these things. So you have to put a lot of intelligence on how you want to deploy your application in order to respect these requirements. And there, data processing comes into play into the various parts, how we can optimally manage the collected data, take advantage of them considering locality, privacy, and it goes on. So a set of challenges that we try to consider for this interconnection. First of all, I mentioned the data locality part. Second, how we can develop efficient distributed management approaches considering the need part of data to be locally processed and part of data to be globally, considering also training of ML models, federated learning approaches, and multi-agent approaches where we want to have local and global decision making. Semantic alignment, it was mentioned a lot in all the presentations, but it's also very crucial for data coming from Internet of Things nodes. And also, one thing that is not mentioned a lot, but it's very crucial also for us, data fusion from the data coming from the cloud providers per se, not the application data, the data for consumption of CPU resources, network resources in telecom operators. Such data may be also very useful for efficiently designing orchestration services. And this is also very important to be considered as part of a data space. So when we speak about meta-orchestration platforms, just to try to give a notion, in the figure on the left, you may have different type of resources managing in the continuum, okay? And then you have different type of metrics that you measure. The metrics can be resource consumption, CPU, memory, traffic, quality of service, but can be also application metrics. How many services I can serve, how many requests I can serve per second, how many videos I can transcode, and it goes on. And all of this come to the definition of a system state. So you have a system state, you consider different type of metrics. And then you have different type of resources on the right. And this type of resources offer different type of ways to manage them. So you have different type of adaptation capabilities and different type of actions that you can apply to manage the resources. So somehow you have to combine data fusion on the left with a lot of learning and orchestration services on the right. And we try to do so in Nefele, following what we call a system of systems approach, where one node has the responsibility for all the deployment, but the control is distributed in different nodes moving across the computing continuum. So intelligence is distributed, and at the end, responsibility is based on one entity. For this, we have developed what we call a synergetic orchestration platform. For this platform, you get an application and you have to manage its operation, and we consider management of compute resources through a multi-cluster manager and network resources. So we combine works coming from cloud and network domains. And important, on the left, we have observability stacks. We collect information from the various levels based on the metrics. And we store data in specific data repositories, but also models, machine learning models that may be applicable. So this information on the left can be very helpful to be shared for training of models, designing orchestration solutions with intelligence, and it goes on. We work a lot on how we can fuse signals coming from resource consumption metrics, CPU, traffic, goes on, traces, software latencies, what is the latency for communication between two software components, and logs. A lot of text in logs in the systems, but you have to process it and analyze jointly the information in a unified way. So, from our perspective, this information, coming also from OpenTelemetry world, is also very nice to be part of a data space, or to be shared with other stakeholders, share knowledge, design more intelligent solutions, gain at the end through optimization of the service provision. Second thing in FLA, it's called virtual object stack. What it is, we have IoT devices, and we have their virtual counterparts at the edge part of the infrastructure. So we have developed an open source software stack aligned with W3C Web of Things, where we enable the development of such objects, and over them, the development of composite virtual objects that consume extra information from these VOs and offer advanced functionalities. For instance, a digital twin could be part of a blue box here. And this kind of objects can be interlinkable with application service graphs. So you have at the end a graph that can be deployed over the continuum. We have a software stack for this, and part of the software stack is whatever has to do with the data. So we collect data from IoT devices, we support different semantic protocols for management of the data, and translators, for instance, between W3C Web of Things and NGSI-LD, or W3C Web of Things and Open Mobile Alliance LWM2M. These data are very valuable and coming from the application, actually, from the IoT devices supporting an application, so they can be really shared. I won't go through it to save some time, but it is the overall architectural approach in FLA, combining the meta-orchestration part, multi-cluster deployment, and the virtual object stack. And as a message, what we would like to work a lot, taking advantage mostly of what exists out there in terms of open source implementations and open source data space connectors, how we can interlink this domain through considering observability data, ML training datasets, and IoT data stores, how we can offer APIs that can be interoperable with data space connectors, so at the end we can contribute to data spaces and also take advantage of all this health of data that currently is not shared with anyone. So, as a final slide, we consider that the sharing and the reuse of data coming from orchestration platforms and IoT management platforms is very important, and we have to support it through proper implementation of data space connectors. And as discussed today, a lot of barriers related to semantic alignment of the collected data, efficient distributed management approaches considering local and global processing of data, and also business models where you take into account cloud providers, infrastructure providers, telecom providers, and also application providers. So that's all from me. Try to be short. Glad. If there are any questions, feel free to make.
Any question? So you were crystal clear.
Yeah. Okay, thanks.
Thank you very much.
Okay, yeah.